Imagine diving into a world that covers more than 70% of our planet. A world so massive, so powerful, and so mysterious that even after thousands of years of human curiosity, humans have only explored about 5% of it. We live on Earth, yet most of it is completely unknown to us. We've walked on the moon, we've sent robots to Mars, we can see galaxies billions of light years away, and still, the deepest parts of our own ocean remain untouched, unseen, and unexplored. The question is not why we haven't tried. The real question is, why is it so hard that even today we can barely scratch the surface? At first glance, this sounds unbelievable. Humans are explorers by nature. From crossing continents to sailing uncharted seas, curiosity is built into our DNA. So when people hear that only 5% of the ocean has been explored, they often assume it's because we don't care enough. That assumption is wrong. Scientists, engineers, and explorers have been trying for decades. The truth is far more unsettling. The ocean is one of the most extreme environments on Earth, and it actively works against human survival. The deeper you go into the ocean, the deadlier it becomes. Pressure is the biggest enemy. For every 10 meters you descend, the pressure increases by 1 atmosphere. That means at just 1,000 meters, the pressure is strong enough to crush most submarines. At the deepest point on Earth, the Mariana Trench, the pressure is over 1,000 times greater than what we experience at sea level. That force is equivalent to having dozens of jumbo jets stacked on top of you. No human body can survive that. Even the strongest machines struggle. Then there is darkness. Sunlight cannot reach the deep ocean. Beyond about 200 meters, light begins to fade rapidly. Go deeper and you enter a world of complete blackness. No sunlight, no horizon, no sense of direction. Humans rely heavily on sight, and when vision disappears, exploration becomes disorienting and dangerous. Artificial lights help, but they create their own problems, attracting deep-sea creatures and revealing only a tiny bubble of the vast unknown. Temperature adds another layer of danger. While tropical oceans may seem warm on the surface, the deep ocean is near freezing. Temperatures often remain just below 0 degrees Celsius. Machines must operate flawlessly in extreme cold for hours or even days. One small failure, one cracked seal, or one frozen component can mean the end of an entire mission. Unlike land or space, there is no quick rescue underwater. You might wonder why we don't simply build more advanced submarines. The reason is cost and complexity. Deep-sea submersibles are some of the most expensive machines ever created. Each mission can cost millions of dollars. There are only a few vehicles on Earth capable of reaching extreme depths, and even fewer that can do it safely. Salt water corrodes metal, pressure stresses every joint, and deep currents can push vessels into underwater cliffs without warning. Communication is another massive challenge. In space, radio waves travel easily. Underwater, they don't. Water absorbs radio signals, making real-time communication nearly impossible. Deep-sea vehicles often rely on slow acoustic signals or operate autonomously. If something goes wrong, help may be hours or days away, assuming it's possible at all. In the deep ocean, mistakes are permanent. Mapping the ocean floor is also far more difficult than people realize. Satellites cannot see through water. Everything must be mapped using sonar, inch by inch. And the ocean floor is not flat. It contains massive mountain ranges, deeper canyons than the Grand Canyon, underwater volcanoes, and constantly shifting tectonic plates. Exploring it is like trying to map an alien planet, but underwater, in darkness, under crushing pressure. There is also the unknown life that inhabits the deep. The deep ocean is filled with creatures that evolved in isolation for millions of years. Some create their own light through bioluminescence. Some have transparent bodies. Some survive conditions that would instantly kill surface life. While these creatures are not monsters, disturbing unknown ecosystems always carries risk. A single careless exploration could permanently damage fragile environments we barely understand. So why does humanity explore space more aggressively than the ocean? Because surprisingly, space is easier. Space has its dangers, but it lacks crushing pressure. There is no corrosion from salt water. Communication is clearer. Once a spacecraft escapes Earth's gravity, the environment becomes more predictable. The ocean, on the other hand, is constantly changing, violent, and unforgiving. Despite all these challenges, exploration is happening, slowly and carefully. Every year, scientists discover new species. Entire ecosystems have been found around hydrothermal vents, thriving without sunlight. The ocean plays a critical role in regulating Earth's climate, producing more than half of the oxygen we breathe and absorbing enormous amounts of carbon dioxide. Understanding it is not optional. It is essential for our survival. So when you hear that humans have only explored 5% of the ocean, don't think of failure. Think of respect. Think of caution. The ocean is not empty space waiting to be conquered. It is a powerful, living system that demands patience, innovation, and humility. And the truth is, the next great discoveries on Earth won't come from the stars. They will come from the deep, silent world beneath the waves. Maybe the ocean isn't hiding from us. Maybe it's waiting until we are truly ready.